So, what is big data? Big data is very much related to data analytics and statistics. It's one of the bigger buzzwords these days, both in business and in education and many other fields. And in the reading, hopefully you learned how big data actually is. Big data is big and it's sexy. Lots and lots of data is collected because of advances in technology, because of the increased dependence of humans on the internet. Essentially, much of our human technological activity is now collected into some database somewhere. 7 billion people using technology to various degrees, and that human use is being measured, collected, stored, and sometimes even analyzed. And in baseball, at the 2014 MIT Sloan Sports Analytics Conference, Corey Schwartz of Major League Baseball Advanced Media announced that Major League Baseball is getting into big data. Corey unveiled StatCast, the new system that was tested in 2013 and 14, and now installed in all MLB ballparks in 2015. The StatCast system involves radar tracking of the actual baseball during the game and video tracking of the players, coaches, and umpires on the field. Some people have estimated that StatCast is going to generate 7 terabytes of data per game. So let's review the definitions of big data that were in the reading. One definition talked about the problem of big data, especially as it relates to typical database software tools. Typical database software tools just can't manage the amount of data being collected. The other thing that's really important is that big data is currently a buzzword. It's a big deal in business today to get into big data, quote unquote, to start collecting big data because it might have competitive advantages for the business, competitive advantages that are either real or imagined. And this applies to many different types of businesses. Another key part to the definition of the phrase big data is understanding the unstructured data and structured data that's out there. Some of the data comes into databases easier because the technology that is generating the data was designed and engineered with data collection in mind, with an understanding that the data scientist might want to look at the data being collected in the future. But a lot of data being analyzed is unstructured, not designed with the database or the data scientist in mind. It is data that is formatted poorly, poorly understood, and sometimes poorly documented. And so that makes it more difficult to process using traditional database tools that might be around. Now, the other part here, which is really important, is it does get big again. There is lots of data out there. So it might be too big for typical analytical tools. Some of the volume of data really is big. It's not just the volume of data, it's the ability to process the data, store the data, make sense of the data. Big data is around, but the key idea here is that the keyword, the phrase, is a buzzword. Business is really into, quote, big data, unquote. And big data certainly is sexy in the business world. But one of the side effects of businesses getting more attracted to, quote, big data, unquote, and being sold on the promise of big data is that big data does not always lead to better analytics. This is a really important point. Big data does not lead to better analytics all the time. So just throwing more data at the problem doesn't get better answers. It still goes back to careful observation of data and good questions generated from those careful observations. Like we talked about the definition of what data science is. Big data doesn't make data science get better, get faster, or get stronger. Data science is not necessarily improved by lots of data. Some people might think big data, more data might lead to more statistical power, and this might lead to better results in our analytics. That just doesn't seem to be the case. Lots of statisticians and lots of data analysts want to try to reframe the definition of quote-unquote big data. And Kaiser Fung of NYU has argued that big data should be redefined under what he calls his Occam framework. This new definition of big data just gets away from the impression that big data itself is going to be the be-all and end-all of the future of data analytics. Data analytics is going to stay the same, big data or small data. But big data has added some new wrinkles to data science. Big data can still be observed, that essential element to knowledge acquisition, careful observation. Careful observation. Important to remember, careful observation is part of data science, whether it's big data or smaller data. And what this essentially means is that the new data doesn't always come from structured instruments that collect data in the way the data analysts want. They come from various sensors that are either measuring weather, for example, or traffic on the internet, or people's behavior as they browse the web. These kinds of sensors are not necessarily designed to collect data in the right framework to answer certain questions that might want to be answered. This is the next point too, that there's a lack of controls in the data being collected. There's lacking controls in the data being collected, and this has to do with various sensors measuring various kinds of data. It's lots and lots of data, but it's just data, and it's not necessarily designed with experiments or questions or careful observation in mind. The other problem is that because it's so big, there's a sense that it's complete. People have a sense because it's so big, it's going to be complete data. That's just not true. There's missing data points in these larger data sets, as well as the previously looked at smaller data sets before big data. Fung describes this as the so-called increasing n leads to the thought that it equals all. The final 2 points about adapted and merged relate to a key piece of work in big data, merging incompatible data sets. In other words, taking different data sets from various instruments, collecting data in different ways, and merging them together. When somebody merges data sets, the big assumption here is that these data sets are compatible, that they can work together. But this assumption is not always true, and it doesn't necessarily merge them completely in the right way, using the right kind of framework to put them together. The bottom line here, as a data scientist, is think before you merge. When you have incompatible data sets, put some thought into it. The point here is that big data is very similar to small data in terms of the fundamental problems associated with data analytics, associated with data science. Data is data. Data is either big, data is small. And remember, this idea that big data is going to get you more statistical power or get you a better answer is probably not true. I really encourage you to read the 2 papers, the 2 blog posts by Kaiser Fung. The URL is at the bottom of this slide. And maybe you'll enjoy playing with some of the smaller baseball data sets in the BU SQL Sandbox later on in this module.